All right, what's going on, guys? So today I'm chatting with Brian Mackenzie. Now we're going to be talking about breathing, stress, athletic performance, and health in general. So first off, Brian, I want to thank you for jumping on the podcast. I actually found out about you through Dr. Andy Galpin, who recommended you and a handful of other individuals for breathing. And since then, I actually attended one of your recent virtual seminars, and I was looking through a bunch of your content, and I was really impressed with some of the stuff that you were sharing, and it was a really interesting little rabbit hole that it kind of led me down. So I'm really glad to have you on today. Do you want to just introduce yourself and talk a little bit about kind of what you've been involved in with some listeners who may not be familiar with you?
Sure. I appreciate you having me on, and I'm glad that you found a rabbit hole, because that's kind of the idea of what we're doing, is to put people into rabbit holes so that they kind of go after what it is they're kind of interested in and why they're there, right? We don't want to dictate. We've worked really hard at dictating the path for people, and more or less trying to keep principles, just trying to break down principles for people. So my what I do is I'm more or less a human performance specialist. I look at human performance from the perspective of efficiency more so than capacity, which is kind of the direction the entire human performance strength and conditioning world has gone. Like, everybody's been looking at capacity the whole time. And although I'm a performance junkie, like, I like to go fast. I like performance. I like capacity. I've worked at that for quite some time. I was really more interested in how this was helping everybody, because not everybody wants to be the best in the world at things. And there was a very dark kind of undertone that was happening at the highest levels of sport that I was seeing, and was not being addressed. And this was only because I'm somebody who was able to recognize this in myself, but then started dealing with athletes in this capacity. My background really started in movement, and expression of movement, and understanding mechanics, namely with running when I began, because there were so many people I was working with that were broken runners. So we dealt with that was my kind of specialty, but I utilized strength and conditioning in order to help these people who were just running, along with moving better. And so that kind of that really evolved over time, over like almost 20 years, into looking at breathing and how that impacts the system as a whole. And I got into breathing because somebody handed me a resistance breathing device that I put on, and I instantly changed my position. I organized myself differently in order to draw breath in from a seated position. And that instantly told me I just organized myself in order to gain better access to my diaphragm. And what I did was, there's a term for this called blood stealing, where if the diaphragm is out of position, so if I'm not organized well, it's not that the diaphragm stops working. The diaphragm's always working, but it's working harder in order to do things that it can't really do well. So if I'm overextended, right, like my rib cage is sticking out, chest is up, and I'm trying to draw a breath, I'm not getting maximal use out of my diaphragm. And in fact, it's being, kind of impinged on, if you will, to work optimally, right? So I'm not able to get the best use out of it. So what's happening is I'm putting more energy towards that diaphragm. And so I'm actually stealing blood from where that blood would be going. Let's just say if I was squatting or if I was running, towards my legs, to be used for that actual, modality that I'm doing, right? Nonetheless, I started traveling down this road of really trying to understand. I grasped the movement and mechanical stuff about this pretty quickly because of my background, but then started exploring the physiology of it. And then started to understand that stress physiology doesn't differentiate between species. And then, really looking into the brain and neurobiology and the neuroscience of stuff, I got enamored with the fact that this is not, breathing doesn't affect oxygen, just oxygen. In fact, it affects every damn thing we do, as it applies to energy, and as it applies to kind of like taking care of the system, including like massaging the brain, including bringing cerebral spinal fluid into the brain and blood out. And, all of this, it's really interesting how it all works. But I just ended up in a very, very deep hole that not a lot of people were in, that I knew were in terms of the human performance world. So my world really evolved about 7-8 years ago, from where I was at to where I'm at now, with we're kind of the only people really talking about breathing and performance in the capacity that we are. And we're having some pretty good conversations with some pretty interesting people like Andy Galpin.
Yeah, and to be honest, that was one of the main reasons why I wanted to have you on, was because breathing is something that I think people take for granted because it's something that we all do. Very similar to dieting. Everyone eats food, and so they assume that dieting will be easy for them, and they don't necessarily see it as like a skill and something to be developed. And so it's definitely really interesting. So I'm kind of excited to hear what you have to say on some of the topics. One thing that I want to just kind of mention that you pointed out was organizing your structure, essentially, and how that influences breathing patterns, and especially going into extension, having that ribcage flare. It's interesting because there's some people who, when they're squatting, I'll have to be like, hey, you need to pull your ribcage down. Like when you go to squat, don't initiate by popping your ass back. Like you need to maintain that same spinal position and lean, kind of like shift your hips, but your whole torso has to move in essence, like together. You can't extend, or else you lose tons of ability to brace. You can't breathe properly. You can't fill your belt. You can't stabilize. And, I've had a couple of people push back, and I'm just like, okay, can you name a single high level squatter who does that? And it's like, I've never seen one, not in my entire life. Anyway,
No, they can't.
Yeah, I know.
Nor can you get a baby to do that.
Yeah, but
because they have to organize correctly in order to squat, get up off the ground.
Yeah, exactly. So I wanted to just kind of start from the basics. So would you be able to give a little bit of a basic breakdown of what actually happens, in your physiology during like the breath cycle?
Yeah. So we draw air in for oxygen. We don't necessarily breathe because of oxygen. Now, that's kind of a loaded answer, in that in reality, we do breathe because of oxygen, because it's what's keeping us alive, because that's how we actually mostly use energy, right? But there is very little, like we're talking micro like things that are dedicated in the human system, in an obligate aerobes system, and meaning any animal that utilizes oxygen for energy as its primary source, dedicated to oxygen sensory. So what happens is we draw air in due to a mechanism in the brain stem where respiration centers are set up, that there's multiple areas, lesions in the brain stem and in the brain, that are dedicated for chemoreception, which is by and large carbon dioxide sensors. These sense carbon dioxide for good reason, and we'll get there in a second. This is what triggers a breath unconsciously. Consciously, you and I have the ability to override it, just like we can consciously go get a cup of coffee or manipulate our diet, because we know how to manipulate stress in order to create adaptive processes. Most of us, right? So lifting weights is this, a manipulation of stress in order to create an adaptation. Controlling our breathing is manipulating a stressor in order to create this. So we draw air in due to these receptor sites that are on the brainstem that are connected up into the aortic and the carotid arteries. So these are outward bound blood flow from the heart and to the brain, right? So it's to the periphery. Those receptors pick up the detection of carbon dioxide here. So this is a guessing game of what might be happening in the system in terms of CO2, as CO2 acts as this mechanism. Well, it plays a very large role in how our pH is managed. If our pH is off just a little bit, like this, our pH is tightly monitored roughly between 7.35 and 7.45. And it can drift outside of those things very easily, but we'll feel a lot of the differences and changes that are going on as a result of that, right? And that'll trigger unconsciously breathing changes, okay? That shift in pH is really tightly monitored through our breathing. It's also monitored with our kidneys, where we can get the unloading of bicarbonate, hydrogen ions, etc. You got all this stuff that can play with the kidneys that'll also play in our pH, but CO2 is largely that big thing. And our way of managing that is by ventilating. So we exhale mostly CO2. We also exhale the unused oxygen that goes into the system that's not actually absorbed in or diffused through the lungs when we inhale. And so when we inhale, we pull in air for oxygen. That oxygen is diffused at the alveolar sacs in through a capillary bed, where it's brought in and then gone through to the heart, to where it's then shot out within the system via red blood cells, right? So red blood cells pick up that oxygen, those oxygen molecules mostly, when it diffuses through the lungs. It's like a little magnet inside that red blood cell with hemoglobin, and that transports it throughout the system to where the oxygen is needed for energy to be used as a coaxing mechanism for enzymes in the mitochondria for beta oxidation, right? So our primary means for using energy is aerobic energy, right? And so aerobic meaning with oxygen. And so the way that oxygen molecule gets off that hemoglobin and and out of the red blood cell is, and here's where this comes back full loop, is by carbon dioxide moving it off of that hemoglobin. So carbon dioxide plays an intricate role in making oxygen bioavailable. So oxygen really is not truly bioavailable until carbon dioxide has played a role in that game. And so we look at CO2 and O2 as like this yin-yang prophecy, if you will, if that makes sense. And so the end product of what happens with either aerobic or anaerobic cellular respiration on how we use energy is there's a carbon bond that's busted, right? And carbon dioxide becomes the byproduct of this energy and is kicked back out of that process of using energy. When we are anaerobic, we become more acidic due to hydrogen ions and more carbon dioxide coming off, right? And so when we're aerobic, there is carbon dioxide that comes off of that process, and it's not as much of that. It's not as much of an acidic process necessarily as aerobic. And this is important because when we become more anaerobic, most of the oxygen that's coming off of those red blood cells is now being used to buffer the acidic processes that are happening through anaerobic cellular respiration. Neither one of these processes is good or bad. They just are. And this is a very basic, dumbed down version, even though it might be complex to some people, of how we use oxygen and what breathing does from a physiological perspective. Now, to bring this even more full circle, due to energy demand through metabolic activity, our ventilation or respiration rate changes as a result of that due to this process with oxygen and then the byproduct of carbon dioxide. So it's why when you start warming up, your respiration rate goes up. because CO2 is increasing, right? So the way we offload that is by exhaling, right? And so respiration rate picks up as a result of that. The harder we work, the demand for oxygen can now increase. And so we may need more oxygen at higher levels. But by and large, with what we've seen, that is not necessarily the case until there's a crossover really within, what we could pretty comfortably say at this point is nose to mouth breathing. So when you need to flip from the nose to the mouth, that's when the oxygen demand really has truly changed. Whereas the CO2 demand has gone up exponentially. And so coming back to the chemoreceptors and the aortic and carotid arteries and the detection system, it's really important to understand what it means from arterial or venous system. If it were the venous system that we were actually detecting from, it'd be too late, and we'd be like this really acidic creature, right? We'd think we were this really acidic creature, where it's predictive, and it means we have to create a relationship to it. And so this means I have a relationship to CO2, which means I have a relationship to my breathing patterns. And every single animal that uses oxygen has what's called a suffocation false alarm system. This is a predetermined area where when I feel really stressed, that means I've really either brought my CO2 levels up or I've suppressed my ability to tolerate that due to cognitive or emotional activity, if you will. So ventilation rates or respiration rates will increase also due to thinking, right? Overthinking in particular. So those of us who are more anxious or who do a considerable amount of thinking, or who stress out or are highly emotional, this will carry weight and will change our respiration rate as well, and it'll speed it up. Because, and this is what's interesting about stress physiology, is that it doesn't differentiate between species. And so we have the power to emote or have emotions on top of emotions, on top of emotions, on top of emotions, where most animals are just stuck in primary emotions, meaning they're happy, sad, fear, or angry, right? And we go like well beyond this. And it just depends on what school of psychology you subscribe to understand primary emotions. It doesn't really matter if you subscribe to 4 or 5 or 6 or 8. The real thing here is that we go into secondary, tertiary, and even beyond with how we look at emotions. And that is where we get stuck in this cycle of survival, if you will, or stress hormone problems, especially as athletes, because those of us who go and train and think we're doing ourselves a big favor in working out and taking care of ourselves, but don't manage an emotional side to things, are actually not doing ourselves favors. And this is where we start to see this swing back to where what I alluded to in the beginning about seeing things with a lot of elite athletes, and even my own athletic endeavors where I was a stress case where it wasn't really happening, where it wasn't really helping me. And in fact, it was doing more damage than it was good. So what all that means is that breathing is tied up not only to what is going on with the brain and our mind, but it's tied up to what's going on with our physiology. And it doesn't matter how or what's going on. If my ventilation rates change, that changes the physiology or the landscape of the physiology. And so a lot of our psychology is tied up into this relationship with our breathing. And we just don't really, what we're seeing is we just don't really see. We see a lot of people who just don't understand their physiology, and that's creating psychological impacts. So the question becomes, is psychology just misunderstood physiology in a lot of cases?
That's definitely a really interesting question. I feel like you could do a series
Oh yeah,
that's just based on that.
for sure.
But I really like how you kind of mentioned the relationship that's kind of the reciprocal relationship between the stress axis and breathing, and how stress impacts breathing, but then breathing also influences stress, and it ends up being kind of this cyclical reciprocal relationship. Can you dive into that a little bit more? Let's say specifically regarding things like maybe depression, anxiety, PTSD.
Certainly. So when you see people who are more depressive, you're going to see you're going to see parasympathetic dominant people by and large. Okay. Now, there are outliers and there are things that can happen. Depression can have anxious tendencies, etc. But by and large, when you look at depression, you see a more parasympathetic dominant or stuck person. So you're seeing somebody who's stuck in this more, I don't want to do anything. I don't want to get out of bed. These are just blanket statements, but right. These are generalizations. It goes far deeper than this. And I'm not here to we could spend a lot of time on deciphering that, but it really comes down to like how people are stuck in a place, right? Like with this side of like how they feel about things. And that inevitably carries weight. And what you'll see is lower respiration rates with people like this, right? So you will see really low respiration rates. Now, this is actually a very small portion of the people we've seen. What we see, and when you look at anxiety or you look at things like PTSD, you're seeing respiration rates that are abnormally high. And so what we've seen, especially within research, is a good friend of mine and a scientist, his name's Dr. Justin Feinstein. He's done work around all of this in terms of clinical anxiety patients who are on meds who are highly intolerant to CO2. So meaning they've just got really low CO2 tolerance scores. And they haven't even really done CO2 tolerance scores. It's just getting any sort of holding of the breath. There's a sensitivity that's going on inside the system that is very abnormal, right? And so people can really take a look at this through a breath calculator test that we've put on our website on shiftadapt.com. Under breath work, you can go to breath test and they can do a CO2 tolerance test. What it is, it's just a max exhale test. And they can see where they fit into the schema of how well they tolerate CO2, right? What we're finding, and we've also got a study that we worked with Preston Spearmont, who's one of Andy Galpin's students. It's going to IRB now. We were able to see that CO2 tolerance is predictive of state anxiety. So when you have more anxious people or people who are dealing with PTSD and depression, you're going to actually be able to screen this through breathing patterns. But you're also going to be able, what we've seen, screen many diseases. Like you're going to understand that there's something wrong. Now, there's not a fingerprint for disease or anxiety. What there is there's a higher ventilation, like you see higher respiration rates by and large due to these abnormalities or these higher stress situations or lifestyles, right? So when I have an anxious person, you see a very high respiration rate. And that is due to the fact that they are highly sensitive to CO2. And thus, when CO2 levels go up slightly, respiration rate unconsciously picks up. And this starts to spin people out. So this really has a huge impact on anybody, really. In fact, faster breathing, mouth breathing is really kind of, you can correlate that with more sympathetic tone or higher arousal states. And slower breathing, nasal breathing, you can correlate with lower arousal states. And this is where we're creative. This is where we're learning. This is where we're doing things. This is where we're aerobic mostly, right? When you get into these higher arousal states, it doesn't matter if you're working harder or you're spinning out and you're over breathing. If you're over breathing at any point, you're not getting enough of the oxygen in the system to be utilized. So you're now leaning that metabolic cart, or, maybe not cart, but that needle, right? More towards higher carbohydrate and even glycogen use, because you've retarded how much CO2 is in the system. And so somebody who is on Zoom calls all day, talks all day, is a type A'er. These folks tend to have lower CO2 tolerance scores because they're constantly blowing off CO2 all day, right? And so that creates that relationship to where if I don't have higher CO2 levels, my pH is now a little more alkaline, which means the moment it shifts back down, I have this connection to higher stress marker, and my brain starts to go, oh, I don't feel good right now. Like, this isn't good for me, right? And I go into these patterns. And so this is where we see things with PTSD and anxiety and depression, where breathing patterns are directly connected to these things. Breathing is directly connected to anything we do, but we can really pick up on this, especially in the anxious department, with people who are highly sensitive to CO2.
Yeah, you said a lot of things there that were super interesting, and then I think really bleed into recovery, athletic performance, and then just even cognitive performance for work, right? Like, and it makes sense actually, because so I'm definitely that person that you described. And I've actually found that I've had to chunk my work into very specific timeframes, or else I just can't keep my performance high. And one of the things that I started doing was just taking, like, I don't know, maybe 2 minutes to just like do really slow breathing just to kind of chill out. And that was kind of like an intuitive sense, because I always just felt panicky. And that has helped a lot. And so it's really funny that you're talking about that. I wanted to hopefully get a little bit more insight into how being in that, higher sympathetic tone would impact, glycogen utilization, repletion, and then, other sort of mechanisms that impact recovery as well from an athletic standpoint.
So if I'm somebody, so let me see if I answer this well to start. So, like, looking in terms of like glycogen depletion, right? Look at your type A'ers. Look at guys like you and I who don't take the time to stop. Like, so most presentations that I do, I start with a story about the lion and the antelope. And it really is about two animals that are in a survival state when a lion goes after an antelope, right? And you've got one that's hungry and needs to eat, and one that needs to get the hell out of there, right? And so they're both in this high level constant state. If we were to remove the picture of this and look at a dashboard, the data points of their physiology, you cannot differentiate between animal. There is no differentiation. You've got two animals, but one's the hunter and one's the hunted, but you don't know which is which if you're just looking at physiological markers, right? So if we were to insert you or I in a very high stress situation that maybe didn't require us to be running, but was emotional or really stressful, those markers would be pretty much buttoned up to each one of theirs, right? The problem here is that what happens after this scenario plays out, right? Let's say the antelope gets away. What happens in the next minute or two with both animals? The lion goes back to his pride or whatever he was doing, lays down and goes back to playing or taking naps. And the antelope goes back to his herd or starts grazing again, literally goes back to eating in a lot of cases, right? What would we do after a highly emotional situation? Most of us hold on to that stuff and drag it through the rest of our day and even our lives. And so we've tacked on this stress, this stress level that's kind of unnecessary. We don't transition well at all. And so if you take somebody who is like talking all day, or who goes and works out and is a type A person and then goes immediately onto the phone and is talking and in a business deal and work, never coming down. The system does not care if you blow off carbon dioxide or if carbon dioxide levels go up or if metabolic demand for oxygen goes up and there's not enough there, right? It doesn't matter. It doesn't differentiate. If the oxygen's not there to use from a biological perspective, it has to lean towards faster energy. That doesn't mean that we're sitting in anaerobic activity all day. It just means certain cells are now getting a higher dose of this more glycolytic side of things, whether it's aerobic or anaerobic, right? And so this is pulling away from these precious stores or our savings account for energy for these high survival-like situations that we need to be in from time to time. And so if we don't transition and come off of that and allow the system to replenish itself or rebuild itself correctly, we don't get the responses we do. We are in complete awe of animals that are not us and how powerful, fast, and everything they do. And yet we run around behaving as though we're the most evolved goddamn thing that's ever happened on this planet. And rightfully so for some regards, right? We are the most adaptive. We're the one that's in every single climate that exists. So we can be in all of it. No other species has ever been able to do that, right? But we're missing very low hanging fruit in this inability to transition. And so if I don't transition from one stressful moment to the next, I'm going to find out that I'm pretty reactive at night, and I may have digestive issues. I may have skin issues. I may have emotional outburst reactive issues. I may have relationship issues. All of these things start to compile, and we just start to believe that this is our story on who we are, when in fact, it was just who we didn't allow ourselves to become because we never took the time to come off of what just happened. And that doesn't mean like going and having this deep cathartic process after I've worked out or after I had an emotional charge with a business deal or my partner, right? It means being able to respond and hear something or see something or feel something for what it is and being able to move on from that. And being able to like, hey, what if I just worked out really hard, what's the best thing I could do for myself? I could come down. So what's the fastest way we have for doing, what's one of the best ways we have for doing that? Breathing directly impacts exactly how our nervous system operates. Like we can grab a hold of our nervous system instantly. So learning to control my breathing after something like that, like you just said, you intuitively did, that's exact. You're just listening to your system. You just listen. You were learning that I can't go and do something all day in this capacity. And that if I chunk it and I take 2 minutes, if I take 2 minutes, I actually perform better at the next thing I do. Weird. And the thing is it's the better you get or the more that you apply to this breathing stuff, the easier it gets and the faster you can grab a hold of your nervous system. Like when I'm done talking, I know I intuitively drop in to shutting my mouth and just slowing my breathing down so that I can actually listen to what you're asking, right? So when we do this, we're actually dipping into energy stores that we don't necessarily need to be dipping into. We could be way more aerobic, which aerobic is the way it's a lifetime, right? Anaerobic is 2 minutes based on, what we understand. And so when I exhaust that stuff, think about this. We're starting to learn. And finally, like a lot of us have been here, but we're starting to learn that just about every major disease is a metabolic disorder. Metabolic meaning the mitochondria do not function well. Do you think your breathing's tied into that? And I'm not and that does not mean I'm suggesting breathing's the problem. I'm just suggesting that breathing has been telling us something. And there's a reason why the oldest movement practice that we know of has breathing at the foundation of it. And why in the hell did nobody in human performance catch on to this and go, wait a second, what if we were manipulating breath for adaptation inside squatting or sprinting or endurance? What could we get better out of this with what we're trying to achieve? There is a time and a place for fast mouth breathing, but there is mostly a time and a place for nose breathing, which is what we found out we are. And when we're nose breathing, you can bet you're leaning more towards using glucose in a more efficient manner than a less efficient manner, and leaning more towards glycogen.
Yeah, it definitely sounds like some of these practices could be extremely helpful for a specific population of athletes who tend to be on that, more extreme end of the spectrum, where they are a little bit more anxious and stressed out in general. You mentioned a couple of times the difference between nose and mouth breathing. So what are the kind of differences that actually occur, and why does that actually happen?
Yeah. I mean, the biggest, I mean, I'll start from the basics. And it's not a lot, but if you really want to look at the reality of your immune system and your health, you got to understand that the air you're bringing into your body is the thing. Like, this is where you're catching most stuff, right? Like, in terms of like a cold, a virus, etc. The frontline defense for your immune system is the air you're breathing, right? And the skin you have on you, right? So the skin blocks things from getting into you, but the air we're bringing in needs to be filtered. So you've got hair inside the nose. You have as many follicles inside the nose as you do on the head of on your head. Shocking, right? It's not the same hair, but as many follicles. That's a lot of hair and cilia, right? Every one of those hairs is coated with mucus. Mucus is it's kind of like it's like the Superman of the immune system. It launches all of most immune functions for everything and anything that you want to deal with for right now to 10 years from now. Meaning you've got these cells, these launch pads for immune cells that remember pathogens and bacteria and things that have come in from 5 to 10 years ago, so that if they come back, it's like instantly destroyed, right? So mucus plays a very large role in that, and it plays a large role in dirt and crap going in, which is where boogers come from, right? Like dirty boogers and blowing your nose. From there, you've got turbinates, which actually spin the air, right? And help deal with a lot of that stuff as well. And with inside, then you go into the paranasal sinuses, which also have some cilia, and it humidifies the air and makes this air compatible for the lungs at this point. Then that air passes down through the throat and goes by the adenoids and the tonsils. So you're talking your third and fourth are tonsils, or adenoids and tonsils. We'll just leave it at tonsils, right? Like, you've got these tonsils that that a lot of people think are just worthless. They are not worthless. There's nothing in the system that's worthless. It's all there for a reason. But I can tell you that if you're a mouth breather or chronically mouth breathe, and you've had problems with sore throats, sinusitis, like you've got problems like your tonsils are now something that are taking on the only filtering for the immune system that happens, versus being the third or fourth thing in line, right? So all that air is actually used in a way that then is brought into the lungs, but because it's going through nostrils, and these turbinates here create resistance. So as I draw a breath, that's my nose. If I draw a breath through my mouth, that's how fast I can get a breath of air in through my mouth. and I pulled as fast as I could with my nose, right? So it slows things down and it creates some resistance. That forces my diaphragm to go, yo, I'm this big primary muscle. I'm actually the primary muscle. I will argue at this point right now, the diaphragm is the most important muscle in the human body. It is responsible for energy, and it is responsible for organization, and it is responsible for just about every process that's needed in this system to function optimally. So that driver of me inhaling through my nose forces more of that diaphragm to really engage and me to get organized around that to use it in a more efficient manner. This is why we will see with a lot of especially endurance athletes and even CrossFit athletes, or even you could say some of the fighters that we work with, that they have a real struggle dealing with nose breathing because positionally they're not in an optimal place. And so asking them to breathe out of their nose means they got to get organized better in order to draw from that diaphragm. And they've been using a lot of the compensatory muscles for that, right? So that's another chink in the chain for not using nasal breathing, right? So the last part, and I believe probably the most important part, is that the big thing with nose breathing at submaximal levels is that it is regulating CO2. Your mouth does not regulate it. Your mouth the difference between my inhale absorption with oxygen is relatively nil from nose to mouth. So the change becomes CO2 out. So I'm actually regulating the pH in the system, and I'm creating this dissociative effect with CO2 and O2 so that I'm actually utilizing more of the oxygen in the system. This is why a free diver holds his breath for 7 minutes and the rest of the population might hold their breath for a minute or two. They're just way more adapted to CO2. And the fact of the matter is you can go a hell of a long time before you die from lack of oxygen. But that pH change and acidity will set all the bells and whistles off and mean I'm going to die. I'm going to die. I need to make some serious changes here.
So how do you go about increasing your CO2 tolerance? Because I remember earlier you were saying that was kind of the sort of the threshold where a lot of these psychological and physiological responses start to kind of trigger. Are there any particular practices specifically that you found to be pretty helpful with this? And how does exercise impact these things as well?
Yeah, great question. I would say all of them can impact it. And this is where it starts to get, this is where it gets interesting. And this is the importance of really the work we're doing, because we're trying to get people to understand how and why we're breathing and what the impact it's actually having on you is. Then here's what the tool is, breathing. Here are the methods. Here's what these methods are intended to do. So if you were to take something like a basic pranayama where you're inhaling for a count of 4, holding for a count of 4, exhaling for a count of 8, and then holding for a count of 4 on the end, if that by and large is slowing down my respiration rate, right? So the moment I slow down my respiration rate, I'm starting to build more of a tolerance, but I'm starting to create some physiological reactions inside the system. Now, if my CO2 tolerance is really high, like mine, so I have a fairly high CO2 tolerance where I can do, roughly a 90-second max exhale test, a 4-4-8-4 for me, or let's just make it even more simple, a box breathing set, 4-4-4-4, right? That really isn't going to do anything for my CO2 tolerance. That's one breath every 16 seconds. And although that's pretty good, I can handle upwards of 12, 12, 12, 12. If I'm calm, right? And I'm not stressed out, I can go 12, 12, 12, 12 and repeat that on repeat, right? And there's people who can do way longer than that, right? So now you're talking about 41 breath every 48 seconds. That is building that CO2 tolerance for me. And this is the importance of understanding where my CO2 tolerance is at, is because for a lot of us, we're simply seeking relief. So what I would do after working out, because of exercise and the epoch, so oxygen demand goes up after exercise, right? But I'm still offloading a lot of carbon dioxide because metabolically I'm still hot, right? So I'm burning through a lot. I would default into just a controlled breathing pattern where I'm probably just inhale, brief pause, exhale, and just trying to slowly slow down my exhale after I've trained, right? Like, so it would just be like, and I'm just getting slower and slower with each exhale as my system is allowing it. And that in turn is going to shift me into a more of a low arousal state and get me more is going to get me parasympathetic much quicker than just not doing anything, right? There are a ton of breathing techniques you could use in place of that. But first understanding that I need to actually, want to grab a hold of something and not stress myself out when I'm seeking relief is important. The development of CO2 tolerance comes in when I'm really trying to push those patterns, right? Like, so if I can handle a 12, 12, 12, I'm trying to do that repetitively for several rounds to where I'm actually creating a stressor, right? I'm not downshifting myself necessarily, or I'm doing a breath hold set. So I could go and do something like, I breathe for 10 breaths, nice and slow and calm through my nose. And then I hold my breath until I have a very strong urge to breathe. And then I breathe for like 9 breaths. And then I hold my breath to strong urge to breathe. And then I go 8 breaths and then hold and then 7. And I work myself down to like 1 breath, right? And then I hold. That is absolutely building CO2 tolerance because I'm limiting my time with how much time I can breathe and offload CO2, right? There are so many things out there that could deal with that, but the easiest thing to understand is I'm just trying to slow it down or increase my stressor of breathing. Now, when I'm seeking relief, I'm trying to calm things down, right? I'm just trying to find a calm place. And this is where just slowing down my breathing fits in, right? And it becomes just this thing where what works for me is what I should be doing that's shifting me down close enough. And the interesting thing here is, you asked about things like anxiety, PTSD, and depression. Well, we all experience emotions and stress similarly, but differently. And we've found that basically not all patterns do the same thing for everybody. And so when I have people who have anxiety have a low CO2 tolerance score, we don't start them off with things with breath holds. Because when does a breath hold naturally occur? It happens in a very stressful moment, right? And you're holding your breath and then you're, right? So we're trying to get people away from that stuff, away from those patterns before we actually introduce them so we can build that CO2 tolerance enough to actually introduce those things. And so within exercise, this is a very important component. People need to move. But we've looked at this, unfortunately, we missed a lot with it. And thinking we can just breathe the way we want to breathe when we're working out and not thinking that this CO2 tolerance has an impact on us was wrong. And although nobody was really thinking of it like that, most of us were just thinking in the terms of, yeah, you just breathe how you breathe, and that's how it should happen. That was incorrect. Because the thing is we're lifting weights or we're sprinting or we're doing endurance work in order to, we're trying to create an adaptation. What's happening with that adaptation? Is there an energy system thing we're going after? Because if there is, our breathing is the fundamental thing that's attached to energy system, right? And so what we did was we created a what's called a gear system. And so understanding that the base layer of the gear system is an equal in and out, nasal inhale, nasal exhale. And most people, we start off their first month, no matter who they are, nose only breathing. And we don't want a mouth breathing for the first month. Then we introduce this gear system concept to where it's equal in and out for gear 1. And then it's a fast inhale, normal exhale, nose only, gear 2. And then fast in and out, nose only, gear 3. And then nose in, mouth out, gear 4. Mouth in, mouth out, gear 5. And we work people into the understanding of how these gears work. And this changes everything in terms of the energy standpoint and creating these adaptations that people are really going after, right? Like it's really just a guessing game from an energy standpoint. And if you're anaerobic, like if you're mouth breathing from the get-go, this just becomes a rapacious cycle that we fall into, and you're missing major gains. Like you're missing major things. That doesn't mean you don't get to mouth breathe. It just means if this is going on the whole time, like how many powerlifters I've seen at powerlifting meets that I've gone to, and it's like everybody's walking around with their mouth open, like just when they're not even doing anything. You see people on oxygen concentrators, football players on the sidelines on O2 concentrators. These aren't oxygen problems. These are CO2 problems. This is a CO2 intolerance problem. And it's absolutely fixable. It's an ego kick because people have to actually take a step back because they're not as efficient as they think they are, even though their capacity is pretty damn high.
Yeah, that makes a lot of sense. And it is interesting, especially because for larger athletes, so I'm a larger athlete myself.
Yep.
Right now, I'm about the lightest I've been in probably like 4 or 5 years, and I'm about 265. So I have sleep apnea, and I definitely have some breathing issues in through my nose. It's chronically plugged. I kind of get like runny nose-ish. And I know a lot of larger athletes who experience really similar symptoms. And so I'm wondering, I would imagine it's sort of like a chicken and the egg kind of scenario where it's like poor breathing probably incites this to some degree. Now, maybe I'm wrong, and I'd love for you to correct me. But then the buildup of some of these sinus issues then reinforces the desire to breathe through your mouth because you don't feel like you can get enough oxygen in. Whether or not that's actually true, and whether or not it's actually an inability to buffer carbon dioxide. But how would you go about dealing with an individual who has some of those types of problems where it's very difficult for them to breathe through their nose?
Starting them off with breath practice in the morning and the evening. So the start of the day, minimum 10 minutes. And end of day, evening, minimum 10 minutes. Nose only, right? And they could go off that breath calculator that I mentioned, and there's 7 different protocols they could play with to find out which ones they like. And really, you just want ones that either make you feel calm and want to go to bed, and then one that just makes you feel calm, but you're still kind of alert and you're there, right? And so there's 7 different protocols people could play with there, but that's where, spending a minimum of 10 minutes doing that, and nobody's going to like this, spending the next month shutting your mouth in all training you do. You're right. It's a chicken or the egg. I'm not here to correct you on anything. You're spot on what you're seeing and learning. It doesn't matter how it happens, but the fact is if you're defaulting to mouth breathing and you're not using the nose, You will have problems with the sinuses. You will have problems with things. You will want to mouth breathe more. It becomes easier. You will pick up patterns and habits like apnea very quickly as a result of this. It's just how it is. The palate of the mouth has changed as a result of that, because that maxilla, because the food that we don't chew as much, that narrows, that changes the structure of how the sinuses work. It's all interconnected. And so really thinking about this from a global perspective of how am I going about my day? What am I doing? Am I supplementing a lot of stuff? Because if you're supplementing a ton of stuff, like meaning it's liquid form or you don't have to chew it, you can bet you're probably deviating into poor breathing habits, because we weren't designed to not chew our food. If you look at the jaw structures of our ancestors, you will see wide, robust jaws, and you'll see perfect teeth. And this all fits in with why we see and saw in indigenous culture very little, if any, mouth breathing, because they paid attention to what was going on. And it turns out you can get pretty fucking fit. It just takes some time while breathing through that nose. You can endure a lot more, and you can develop a very high level CO2 tolerance that doesn't necessarily require you to spend a lot of time in a breath practice, because if you're actually actively, consciously engaging in shutting your mouth during training, that is a breath practice. Like, that is engaging. And so those first steps for people are just an ego kick. And this is really what it, the work has really come down to is, athletes are no different from the general population. People who train and have to train are no different than the general population. They're just taking the neurosis out on the actual training. And so the need or have to train to get that feeling, to get those changes, becomes the catalyst in why I'm actually having the difficulty that I am. And so we have people who are such performance junkies that their entire lives are based off of metrics that don't matter. They only matter in a mind that doesn't know the difference between capacity and efficiency. And it doesn't. And what I did not say there is that you couldn't go be a world champion and you couldn't go win something. You can absolutely and should go after those things. You just have to understand the consequences of, if winning is everything and the only thing, or points and lifting a specific amount of weight are the number one thing, you are going to find a problem at some point. Because what we've found at the foundation of all training is the ability to make a better decision and understand why I'm using this training. And it's so that when I'm in a stressful situation, I'm responding and not necessarily reactive in a default state to where I don't know how to manage things, right? Like, I'm really learning how to grab a hold of this stuff and get what I want. This is really actually just giving people real power. It's like, truly, like, what do you want? What are your boundaries? Oh, turns out you aren't as fit as you think you are, even though you can go through brick walls and you won. Your health actually is being compromised right now. And breathing is just this marker that we're seeing that is first to the, right now we're seeing is first to the line to tell us, hey, something's off there.
It's so interesting because as you're talking about this, I've honestly got, like, I'd say 80% of the questions that I had written down left, because I've just found it so interesting hearing you go off on like the different tangents. And then as you say stuff, like different things come up. And so I'm kind of led down different corridors. So I wanted to explore a little bit more about like physiology, specifically within the gut. I know you talked a little bit about immune function and other physiological markers that are kind of impacted, like, well, I guess implied anyways, like blood pressure, heart rate, resting heart rate, things like that would be impacted by breathing. But I wanted to know what sort of relationship exists between breathing and digestion and gut health in general?
Well, we were involved in kicking off a study, and we're still waiting, and it's going to happen at some point with Dr. Jimmy Bagley at San Francisco State on and Ryan Dirk, who we're going to look at nasal breathing and training and the gut microbiome with athletes who didn't do that, and the changes that occurred. For myself, and this is really who I can talk about, is I've had a complete change in how my gut functions just due to breathing. Now, if we take me out of it, let's just go with principles. We used to use the terms, and some of us still do, rest, digest, reproduce for parasympathetic nervous system, and fight, flight, freeze for our sympathetic nervous system. Now, also a part of this autonomic nervous system is our enteric nervous system, right? So that's a whole host. That's an entirely different, like almost nervous system in and of itself. But there is direct impact from being more sympathetic or more parasympathetic on how I digest and how my gut works. So from a principle standpoint, there's no way it can't have an impact. How much? That's where research is going to find out. What's going to have the biggest impact? That's where research is going to find out, right? But there's no if and buts about it that breathing does not change the gut and controlling that breathing, because we're taking something and dropping it into a space to relax the gut so that we can actually use that gut, versus I go into fight, flight, freeze, and all of a sudden everything shuts down, but I just, had a huge hamburger or whatever you just had. And all of a sudden I've got, I'm on the toilet, right? Like, a couple hours later, getting rid of everything, and that's just an extreme version of what's going on. But I can't tell you how many people I know that, are your sympathetic type A dominant people who have gut issues and are over breathing that we run into. Is it directly tied? I don't know if it's directly, but I know that they are connected. And that when we get people to start to shift more and learn how to transition better, a lot of these gut issues start handling themselves a little bit better. Not saying it's the whole solution at all. Like, it definitely is going to have to do with what you eat and how you're eating. But, I find it odd that we've got more people allergic to more crap now than we've ever had in our history. Just like we have more people dealing with disease than we've had in our history. And yet we're starting to see how this is all interconnected into this kind of emotional side that affects our, the metabolic function of the cells, right? Like that stress of emotion and being suppressed. And I mean, look, we're in a very stressful time right now. People are internalizing a lot. People don't have community like they used to have. That is an important thing. These are all important things. And so that stress affects everything. And if we haven't learned how to deal with that stress, and we're just dragging this childhood way of managing, how we weren't seen or heard or whatever happened to us when we were little, which most of us do. We drag a portion of us through our lives as though this is how we handle stuff. That is having a massive impact on us physiologically. And we might eat. I mean, I know people who have had cancer multiple times. I know people who've had diseases multiple times. There's a great book out there by Dr. Gabor Mate, who's a Canadian. And it's called When the Body Says No. And it truly outlines all of this and people coming to terms with things. And one of the most gnarly things that he pointed out that was really quick in this book was that he had a patient, and he had a private practice, and he's looked at, and he's got the research and stuff for all this stuff, but he's like, look, I had a patient who was molested from the ages of 8 to 14. And you know, he literally just lined out how this kid was, you know, beaten as a child, right? But decided for the next 30 years to beat himself because he didn't know how to manage and deal with that. Does that mean that that kid should have learned to deal with that better? No. What that means is that whatever happened when we were younger and how we managed it, if it didn't learn to appropriately shed that, to deal with that, and I'm not suggesting that like I've dealt with that. I have dealt with many things close to that, but it's really learning how to process these things and let go and move on, because nature does not care. And as harsh as that sounds, we are nature, and our physiology is our nature. It's why you can't differentiate species to species. And when you really look at it under the microscope, it's literally this thing that's functioning the way nature functions, and it's just doing what it's told. And if we're in this high stress state of a kid who has to win at every single game, but who never learned how to lose, and that in life, you're going to lose a lot. Like, there's going to be a lot of downs. That's going to be a very difficult process. But the thing is, that's not my area of expertise. My area has become that breathing pattern's off. There's something going on. We can fix this. There is way more potential. You are a world-class athlete, and you can learn to be even better. And that's what really is, you know, important about all this stuff, is that we've got so much more ability to learn about ourselves, whether we're a world-class athlete or whether I'm a mom or a dad or a kid. Like, just giving them the understanding of this and the tool to regulate themselves so that they're not really falling off the, you know, the cart, you know, and not being able to manage things or recover from things. And is, you know, some people are probably going, yeah, I don't deal. Yeah, I'm fine. You know, like, none of this affects me. They're wrong. This affects every single one of us. We all were children. There is, in every one of us, there isn't a person I haven't worked with in the thousands of people that doesn't have some sort of issue that they aren't dealing with, that they didn't deal with from their childhood. And it's really like coming to terms with this stuff. So the fact is it's all interconnected. And until we actually want to look at that, it's just not going to work. And the sooner we get to that, the better, the more optimal, the more efficient we become, and the more powerful we become, and the less personal we take stuff, and the easier it is to be friends with more people.
Yeah, I really like how you made that distinction about just nature. I mean, there's quite a few instances where I would say that I have definitely like parallel beliefs around, just generally speaking, like, you know, you're in a difficult situation, but are you going to focus on the fact that maybe something is maybe unfair, or are you going to try and focus on, hey, like, what kind of outcome do I want? You know, and yeah, the reality is a lot of the times that just what you have to do to get the results you want is,
how many times did you go lift that it didn't work out like the way you wanted it to? Almost all of them, right? Yeah. Like, so it's just expectations.
Yeah.
Like,
no, and I honestly think that that's a way more empowering mindset. And I know obviously right now we're kind of delving into a little bit more of a philosophical discussion, but
yeah,
I think that, in my opinion, it's a little bit more of a productive mindset, because it really puts the power into your hands. Like, if you say, hey, everything is my fault, not from a standpoint of like shame or blame or whatever, but it's just like, you know, what are the things that I can control? And then kind of extend a little bit beyond that and be like, okay, I'm going to take responsibility for being rear-ended. How can I take responsibility? Even though it wasn't my fault, how can I take responsibility for that? And I find that if you have that mentality anyways, there's so many things that you can do, and you're going to be able to like change your circumstances and change just even your response to different situations. And then even more importantly, in my opinion, the speed at which you can make decisions. Because usually there's like a lag, something bad happens, and then you're sad about it for a while, and you're kind of mulling over a bunch of different decisions, and you waste time. Whereas if you can look at a situation and be like, okay, this is what's going on. All right, cool. I'm going to make this decision. Boom. It's like you can cut your experimentation time like by 80% just because you can keep running things immediately, and you don't necessarily have the same level of emotional attachment to all this stuff because you're like, hey, it's purely outcome. I didn't get the outcome. Awesome. That doesn't mean that I'm a bad person or, the world is out to get me. It just means that I didn't get what I wanted. So how do I change things so that I do get what I wanted?
Yeah, it's responsiveness. And it's like, look, you make Viktor Frankl, it's like in between choice and response, like in between stimulus and response is choice, right? So you're in your car, you get hit. It's not necessarily you need to take responsibility for getting hit, but you are responsible for how you respond. So if you want to be an asshole because you got hit, do you think that person actually wanted to hit you? Like, is that what they did? Maybe they ruined your day because they hit you, but do you think they meant to do that? Did you ever mean to hit anybody? Like in a car? Like, have you been in an accident, right? Like starting to really reflect on these things is where the response is actually important. And it's like, you were on the road, you took the risk of being in a car, which runs the risk of getting in an accident with another car. But here you are, and how do you want to respond to that? And that's where it's like, hey, if I didn't hit my lift, is me getting angry about that? Has that ever helped me? I can bet never. It's never done anything other than made you angry or emotional and re-triggered something, right? And confused you into believing in an illusion to where I didn't hit that lift. Damn. Well, maybe next week I'll get it and I'll see where I went wrong this week.
Yeah. And I feel like that ties in really well just to the initial stress response that tends to be that kind of knee-jerk reaction to stress in general, whether it's, getting hit by a car, having a difficult situation, having a bad training session, maybe being frustrated about the results you're seeing in the gym or really anywhere else. And so I really like how you kind of tied all that stuff in together at the end. So we are kind of coming up on the 90-minute mark in the next couple of minutes here. I just wanted to know what kind of resources would you recommend, or do you guys have? Because I know you guys do provide quite a few resources.
Oh, we've got an absolute metric ton of resources. So on shiftadapt.com, we have a membership site, right? And on there, we have our education, which is our webinars and our webinar series. I think there's over 20 different webinars right now. They're free to membership, right? Then there's the actual training that you can see how we use that gear system within training. Not that you necessarily need to follow the training, because if you're following something specific, that's perfectly fine. But you can get an idea of how the breathing and the gear system is implemented. Then there's actually breath work, daily breath work that you can get in order to create these adaptations that we're talking about, right? And then beyond that, we have what is our Art of Breath and Skill of Stress courses. So these are more of these are paid, these are standalones. The Art of Breath really goes into what, how, and why, right? It distills down the principles. It teaches people how to use this stuff. It gives them so that they can go and utilize this in the capacity they want to. And then the Skill of Stress is really understanding how we manage stress and deal with stress and using breathing and how breathing applies to that in our daily life. They're really great courses that really help lay the foundation of understanding all this stuff.
Awesome. That's great. And so where can people find you? I know you mentioned .com. Are you on any other social media?
No, I don't really jump on any other social media stuff unless I'm like directed to be on like some Facebook group chat or something. In fact, I'm not even on Instagram that much, but I do have a presence there. So my Instagram handle is @_ Brian Mackenzie. And then you could also go to my website as well, which is brianmackenzie.com. and that's just informational stuff. And I have my mentorship stuff on there, which, is pretty booked out, but from time to time we get openings on it. Nonetheless, everything I've covered today is on shiftadapt.com. So on Shift.
So all that stuff is going to be linked up in the show notes, guys. Definitely go give him a follow on Instagram. Check him out. Check out his website. And also, Brian's been kind enough to offer myself, as well as all the listeners, a free 1-month membership to his website. So definitely go check it out. He's got a ton of great resources there that will definitely be worth it. So the promo code for that is Stacked Podcast. Again, all of that information is going to be in the show notes. So definitely go head on over, check it out, and get your free membership. Brian, thanks so much for joining us, man. It's been a pleasure.
No problem. I appreciate you having me on, Daniel.
Yeah, man. All right, take care.
All right, brother. Thanks.